This is AP Calculus 3.5, and in this section we're going to select procedures for calculating derivatives. And we've done everything from this section already. We're just now going to combine different methods. We've learned the power rule. We know that if we have several terms added together that you can add their derivatives together. We've learned the quotient rule, we've learned the product rule, and we've learned the chain rule. So, and we can couple all of those with all of our trig derivatives that we've learned. So sometimes you're going to have different functions that they're going to ask you to find the derivative of, and you're going to have to recognize which of those different procedures we're going to use to actually find this derivative. So here they're wanting me to find the derivative of x cubed plus 5x times sine x. Well, the first thing I see there is this is a product rule. So I'm going to use the product rule. This is my first thing and this is the second. So if I have the derivative, I'm going to take the derivative of the first thing. I've got 3x squared plus 5 times the original second, that's sine x, plus the original first, that's x cubed plus 5x, times the derivative of the second, which is cosine x. And then if I can combine anything, I will. In this case, there's really not a whole lot I can do. I could distribute here and here, but that's really not going to give me any like terms. It's not going to give me anything. I don't have any common factors that I can take out. So for this one, that's really all I can do. Some of these are going to have kind of lengthy answers with not a whole lot of simplifying you can do. With this one, I'm going to use the quotient rule. I've got a top and a bottom, so I'm going to use the quotient rule. So first I'll rewrite that. That's the same thing as 3x squared to the 1/2. So not only do I have to use the quotient rule, I'm also going to have to use the chain rule to take the derivative of the top part. So that's going to make things a little more complicated. So to take the derivative, I first take the derivative of the top. Well, that derivative of the top utilizes the chain rule. I've got 1/2 times 3x squared to the negative 1/2 times the inside part, which is 6x. I multiply that times the original bottom, sine x, minus the original top, I'm going to write that as square root of 3x squared, times the derivative of the bottom, which is cosine x, and that's all over the bottom squared, sine squared x. Then I'm going to simplify whatever I can. So looking over here, the 2 goes into the 6 3 times. So I've got a 3x over the square root of 3x squared. I can put that on the bottom. And then that sine x goes to the top. Minus square root of 3x squared cosine x. And that's all over sine squared x. Well, I know that that's a complex fraction. I can't leave it like that. So I need to understand that's the same thing as sine squared x over 1. And I can take that and I can multiply it by 1 over sine squared x and have the exact same thing. So if I do that, then I can distribute that 1 over sine squared x. So I would have, when I distribute this, 3x sine x over square root of 3x squared times sine squared x. Now, hopefully you recognize sine x over sine squared x. That will cancel. So I can get rid of that sine and get rid of the square. Then if I multiply this one, I'll have minus the square root of 3x squared cosine x over sine squared x. Here they want me to take the derivative of x squared plus 3x minus 10 all over x minus 2. The first thing I'm going to try to do is factor to see if anything will cancel out, because if I can make it simpler, it'll make the derivative easier. So are there factors of 10 that subtract to give you 3? I'm thinking 5 and 2 would work. So let's say x and x. We've got a 5 and a 2. Signs are different. The 5 gets the plus, the 2 gets the minus. And if you look at that, we've got a factor that cancels out. So now what you're really going to find is the derivative of x plus 5, which is just 1. So that one can be simplified if you notice that it can be factored. Here are a couple more. With this one, that's the same thing as x to the 1/2, and that's over x to the 3rd. So I could rewrite that one. I could write that as x to the 1/2, 1/2 minus 3. That would be 1/2 minus 6/2, or negative 5/2. So that would be x to the negative 5/2 if I just rewrite it first. And then the derivative is real easy. Negative 5/2 x to the negative 7/2. And then I just need to get rid of the negative exponent. So I've got negative 5 over 2x to the 7/2. Over here, I can also rewrite that. If I rewrite it, that's the same thing as 3x minus 10 to the negative 1. And here, it's going to be a lot easier to use the chain rule than it is to use the quotient rule. So if I use the chain rule, the negative 1 times 1 is negative 1. I keep the inside part, decrease my power by 1, and then I take the derivative of the inside part. So to simplify that, that would be negative 3 over 3x minus 10 squared. In this one, we've got e to the sine 4x squared. For that, to take the derivative of an e function, remember you take the original e function and rewrite it. So that's e to the sine 4x squared. And then I take the derivative of the u part. Well, now let's think about that. If that's our u part, to take the derivative of that, the derivative of sine is cosine. So I would have a cosine 4x squared, and then I need to take the derivative of the angle part, which is 8x. So the du, or the derivative of the exponent part, all of this would have to be put in front of the e. So that would be 8x cosine 4x squared times e to the sine 4x squared. This one's a little complicated. If you look at this, you got cosine of the angle part. The angle part here involves a natural log. So not only do you have to take the derivative of the cosine, you also have to take the derivative of the angle part. So if we take the derivative, first we deal with the cosine. Derivative of cosine is negative sine, I'm going to leave a little space, times the original angle part, so that's natural log x squared. And then we have to take the derivative of the angle part. So that would be the natural log of x squared. To take the derivative, we take the derivative and put it over the original. So the derivative of x squared is 2x over the original x squared, and then we can simplify that a little bit. So that would be a negative 2 over x times sine natural log of x squared. And that's all we can do with that one. Here's our last example. In this one, you have to look at what we've got. We've got a x cubed, and then we've got a tangent squared 3x to the 5th. That's a two-part problem. We're going to use the product rule here because we've got two terms multiplied together. So when we do the product rule, the first term derivative is 3x squared. We have to multiply that by the original second term. We're going to add that to the original first times the derivative of the second, and that's where it gets a little complicated. We have to use the chain rule within the chain rule here. So first we have to take the derivative of the outside part, the tangent squared. To do that, we do 2 times tangent to the first of the angle part, 3x to the 5th. Then we take the derivative of tangent, 3x to the 5th. The derivative of tangent is secant squared. So we have we're going to multiply by a secant squared of the 3x to the 5th times the derivative of 3x to the 5th. So that would be times 15x to the 4th. And then we just need to simplify that a little bit, make this look a little bit nicer here. So for this one, there's really not a whole lot we can do. 3x squared, tangent squared, 3x to the 5th. Over here, this 15x to the 4th needs to come out to the front. So the 15x to the 4th times 2 times x cubed would be a 30x to the 7th times tangent 3x to the 5th secant squared 3x to the 5th. And then we could take out anything that they have in common. So notice here this 3x squared is common to both terms, and the tangent, one of the tangents is common to both terms. So we could bring that out, and then we would have a tangent left in the inside, plus, we brought out the 3, so we've got a 10. X squared was brought out, so that's x to the 5th. The tangent was brought out, and we have a secant squared 3x to the 5th. And I think that's probably all you're going to want to do. Some people like to leave it like this. It just really depends on what they ask you to do. If they ask you like to find the horizontal tangent lines or something like that with this problem, you would need to have it in factored form to be able to do that. I'm not sure they would ask that with something that's quite this complicated, but who knows, they may.